How's it going? Welcome back to episode 8 of the Cyber Bike project. Last episode we left off with the brake calipers and working on the rear swing arm. And this episode we're going to be working on the front swing arm. Yeah, swing arm on the front. Motorcycles normally have shocks, but some of them don't. And today we're going to talk about why they don't and what is the difference between having shocks versus swing arms, the different kinds of front end swing arms that you can get. So, let's get straight into it. There's going to be a lot to go over this episode. It's going to be a bit like that episode 6. Yeah, it's going to be a bit like episode 6. Lots of talking, lots of stuff, lots of information. Let's get into this now. The different kinds of front ends that you can have on motorbikes. Normally, they are just the forks, but the problem with forks is they do strange things when you're steering, or when you're going around corners, or when you're braking, especially when you're braking. It's called front end dive, and when you're under braking going into a tight corner, when you compress, all your weight's pushing forwards from the braking force, which compresses the front shocks. And when the front shocks are under compression, they have less travel, and going through the corner, if there are any bumps or changes in the corner, then you've got less travel for those shocks to do their job, and thus you get judder, you can have slip outs, where your front end falls out from under you. It's not good. There's a lot of problems with front end shocks related to cornering, braking, and stuff like that. Here's a good image that shows how you get lateral displacement under certain conditions. And then also, your application of your braking force puts the front shocks under compression. There are lots of different problems that come with front end shocks, but they are very simple, they're easy to manufacture, and they're very common. They're all over the place. Everybody uses them. That's why they're industry standard. But we're not going that way because reasons. I don't know, sue me. No, just kidding. There are some really good reasons for why we want to use a front end swing arm over a set of shocks or using any of the other systems that I've described. The main reason is the compression in braking, or having the front end dive when you're braking coming into a corner. And the best way to explain how this works is to just, show you. When a bike with a front end swing arm starts braking, the majority of the braking forces travel directly through the swing arm, and very few of the forces actually travel through the shock. When you're braking, all of the mass is slightly higher up than the swing arm. So yes, there is a small amount of force that wants to dive the bike forward, to tilt it forward, but on a whole, most of the braking forces come through the swing arm and into the chassis and stop the loading on the shocks. And that's the key reason there, is to prevent loading on the shocks into cornering, which means you can brake much harder coming into a corner, and you can go around the corner with quite a bit more speed, because when you are no longer braking, when you're entering the corner, your shocks aren't compressed. Your shocks on your front have a lot more travel. They've got a lot more play and a lot more give, which means you can attack the corner a lot harder than what you could with a regular bike, because the shocks aren't compressed. And then you also aren't transitioning from having the mass in that dive position to then not being in the dive position. So the whole transition through the corner remains a lot more stable because of this setup. And that's the number one reason why we're going with the front end shock. The second reason is because it looks really cool, and the third reason is because we're not using shocks, we are going to have to look at what are we going to use for the front end. Now, in the drawing, I was a little ambiguous with this scribbly mess, because I wasn't sure myself what I wanted to do. In my previous bike design, I used a hub-centered steering system. Now, this is a hub-centered steering system. It's a lot less complicated than it looks. This is a top-down view here. So this is top-down here, and you can see these are the two extremes of the tire, the cross-section of the tire. So the tire can turn between this angle. And there's an axle that runs between the hub, which connects to the swing arms, and that hub is pretty hollowed out, and there's this double hinge thing on the inside that allows for the wheel to turn around this cross axle, which is this one here. So it's complicated, but it's a lot simpler than people think. It's actually pretty easy to design. So that's what I used in this old bike design of mine, and I quite like it. It's very simple. It's not a huge issue. I would have to go back and redo the front rim. I'd have to redesign the front rim. I'm thinking of redesigning both the rims completely anyways, so this could be, you know, the pusher. If we go with a hub-centered steering, then that's going to be the deal. We're going to have to go ahead and redesign the rims, which I'm not opposed to. Like, they look cool, but they're impossible to manufacture. They would have to be laser sintering with metal printing. It's just not doable. But, you know, it's a concept bike. It's not actually going to get made, so I'll have very loose requirements on the design aspects. I can do what I want because it's the thing I'm doing. So, but yeah, so I'll probably have to redesign the rims, and then we'll look at that at a later date. I'm leaning towards doing another hub-centered steering system because they are actually a lot simpler than going through and using one of these. Now, these are the three other parallelogram. They're like a hybrid between a hub-centered steering and a shock, using the yoke and shock. These all rely on a parallelogram of a displaced yoke, so it's like taking the shocks off of the bike but keeping the steering bit, the yoke, that's the bit where the shocks rotate around on the steering axis, removing that from the frame of the bike and putting it on a parallelogram, and then putting a shock inside the parallelogram. You know what I mean. The thing with the two sticks that pivot on both sides, right? So that's basically just taking the yoke of a front end steering shock system and displacing them from the bike using parallelograms. There are the three different variants: the Parker, the Elf, and the Hosek. These have shown up in various different forms throughout the years. I found a really nice old image of a BMW. This would be a Elf system. So you can see here you've got your parallelogram running from below the shock here to the frame, and you have the secondary one here. This here is your yoke and your steering axis, and then you'll have this linkage here which goes through a series of linkages up to the handlebars, which controls your steering mechanism. You can see here this old BMW also had a perimeter brake disc as well, so they've been around for a while. It just goes to show this isn't new stuff. Nobody has a patent on them. I mean, a few motorcycle manufacturers have patented their own steering systems, but they're patenting specific aspects of how their one works. They're not patenting the concept or the function as a whole, and this is a key distinction to make. This is the same as with Eric Buell's perimeter disc patent. His patent was for specifically how the perimeter disc attaches to the rim and how the rim is designed. And even his patent, there's a lot of discussion about its validity and its legality, because it's vague, and a lot of the things that it claims in the patent are things that have been done before, so he couldn't necessarily patent them, and it wouldn't hold up in court. If you tried to take somebody to court for doing something, it wouldn't hold up because it's been done previously. It's not a novel concept. That's the one I was looking for, novel concept. Now, what else we got? We've also got this. This is of a Honda. I think this is a custom built. This would be a Hosek. So with this one, the way this one works is you've got your steering axis is here, and the parallelogram runs off here, and then you'd stick your shock in somewhere here. So with this, your handlebars are still attached directly to your steering axis, and you're feeling the shock. Your handlebars would actually move independent of the bike frame, I think, unless they've got it separated here by these. They do. So, okay. So yeah, the handlebar would stay separate, and then there's this linkage here which attaches to the steering axis. So there's another example of a steering geometry setup. There's been all sorts, like there's so many. This one, I'm not sure, I think this was a custom built bike, but yeah. So this is a front end, a hub centered steering. So the steering geometry is within the hub, but it is a combination. It's like a hybrid system. So it's like a combination of the Elf system, a hub centered steering. The steering is happening on the inside. Your swing arm is fixed. So the bit that holds the wheel to the frame is fixed. It doesn't rotate. And that's the distinction between these setups and this setup. With this setup, the bit that holds the tire to the frame is this bit here, and it's not directly attached to the frame. It is then attached through two more linkages that have a rotational axis, whereas this one, the steering axis is here, but the bit that holds the wheel to the frame is fixed. There's no steering axis on it. There's an additional control axis which handles the steering that is separated out. this is an overly complicated system. Like, I don't know. Like, my favorite one that's been done to date has been done by there's two of them. There's two motorcycle makers that have made some really pretty front end steering systems. This is both Italian, believe it or not. This is the Virus motorcycle by Virus Motorcycles. Now, what they do is they have a very interesting business concept. They design the bike, the frame, the crate, they call it the cradle and everything, but the motor is from another bike. So if you have a bike with a motor that you really like, you can say, hey, look, I would like my Virus to have this Honda engine, or I would like to have a Yamaha engine. And they have different cradles that hold the different kinds of engines. So you can have a 600, or you can have an 1100, you can have all sorts of different things. And they also have, I think they come standard with a Suzuki motor that you can buy it, just they sell them as is. But yeah, so there's the Italian Virus motorcycles. And then there was the Bimota. Now the Bimota is also a really nice Italian motorcycle. They also use the front end swing arm. It's very simple. You have a parallelogram that prevents your steering axis from rotating on the front end swing arm, and then you have an additional linkage that controls the actual steering axis. So if we were to look at this image here and try and explain how this image relates to the Bimota, let's focus on the Bimota. So these are three different images of the Bimota front end swing arm. This is a model kit that you can put together. I'm actually going to see if I can find this model kit and buy it because it looks really cool. There are three main components to hub-centered steering. And we'll use this. This is a Bimota hub center unit. So you have 3 points of control. You have your main swing arm. This is what controls your shock dampening and your movement of the wheel up and down. Then you have your parallelogram, which is these bars here. These control your rake angle. Rake angle is the angle at which the steering axis relates to the motorcycle front and back. You don't want your steering axis to be perfectly vertical. You'll end up with a lot of wobble. But you don't want it lean too far back because then you lose steering capability. You'll see that with a lot of choppers. They've got a very extreme rake angle, and when you turn the handlebars, they've got a really shit, like, slow speed turning radius. And then the third aspect of the hub-centered steering is your steering axis. So these linkages here, they control the angle of this in relation to perfectly vertical, which would be like that. So they control that angle. They also keep that angle parallel to the motorcycle when the motorcycle is going over a bump and your swing arm moves. And then the last one is your steering axis, which rotates on this axis here and is controlled by a linkage that comes off on either side depending on the design of it. The Bimota one, their steering control is done. Yeah, so here you can see this linkage here controls the steering. These are my options. We can go hub-centered steering, we can go hybrid like with this one, or like this one. This I found this while I was looking for stuff. This is a new motorcycle. This is an electric motorcycle by Arc Vector. This is their new e-bike. I wish I had money. That's a really nice bike. It's very close to what I'm building to begin with, so what I'm designing to begin with. So that's a really nice bike. I really like this concept. I would love to own one. This is a hub-centered steering design, but their steering is controlled through a linkage that comes down from the top here, and then the parallelogram that controls the rake angle is up top here. Here we go, steering axis with blue. So the steering axis is controlled with these linkages here, and then you've got your swing arm here, and the parallelogram that controls your rake angle is here. So yeah, this is a very elegant design. We're going to go with something similar to this, but not. I don't like this dropping down from the handlebars. I don't know why, I've just never liked it. It's so many like linkages in that have to move with the shock and the whole swing arm. I don't like it. And it looks ugly just having these weird fiddly bits hanging out. I'd much rather have a linkage that comes off to the side and then runs up with the frame of the bike to the handlebar. So yeah, that just about covers it. There's a lot. Again, engineering is beautiful. I love engineering, especially when you start getting into things that have been around for a while. Aircraft, motorcycles, cars, heck, even just simple stuff. Like, there's so much history and information for you to get into to discover why things are the way they are and how they work. And I really love that about engineering. That's why I do this. That's why I love this. That's why I'm so passionate about this sort of thing. And yeah, so we just covered there a whole load about swing arms, front end shocks, and hybrids, combinations, all the different variants that you can put these things into different arrangements to get the same result. You just want to steer the front wheel, but there's 1,000 ways to skin a cat. So yeah, we'll leave that there for today's episode. We covered quite a lot today, and next episode we'll get into the actual CAD design of the front end swing arm, and you get to see what I've done off camera, which is the linkages for the rear swing arm, and I'm going to look at doing the linkages for the brake calipers and how they're going to attach, but I want to get the front swing arm assembly done first. So until the next episode, I'll see you guys later.